so let's walk through our steps for a projectile motion problem, just to refresh our memories. So here we have a soccer ball that's kicked at a 45-degree angle, and it's kicked with an initial velocity of 9.3 meters per second. So I've gone ahead and drawn a little diagram here, a little right triangle, right? You remember if something's, kicked or thrown horizontally from the ground, you can break its vector of its initial velocity into components, right? So you can break it into a vertical component, often Vy, and a horizontal component Vx, right? And these two vectors, Vx and Vy, when added head to tail, right, their sum equals the vector of initial velocity. And remember, we can treat these two vectors as distinct, right? The vertical motion of the ball and the horizontal motion of the ball do not affect each other, right? And you'll recall, hopefully, that in the x direction, the ball follows constant velocity model. It has no acceleration. So we can apply CVM equations to the x direction, right? The only real big CVM equation we have is velocity equals displacement over time, right? Change in time. And then in the y direction, right, we follow CAM, right? Constant acceleration model. And here we've got plenty of options for equations, right? We can use any of the big four in constant acceleration. So what I like to do here is list what variables I have and what we're looking for. In this case, the question asks, how far horizontally does the soccer ball fly? So that means we're looking for displacement, right? Change in x. So we don't know change in x, that's going to be a question mark. That's our big old question mark, right? If we answer that, we've answered the problem. We get to go home, right? We're not given a change in time. And we don't have a we don't have a velocity in the x direction yet, but we could solve for it from this triangle, right? Remember, we could use a little trig to solve for Vx, right? So in this case, Vx is adjacent to the 45-degree angle, and we have the hypotenuse of the triangle. So we could use the cosine, right, of 45 times 9.3 meters per second, right? And that's going to equal the velocity in the x direction, right? This equals 4.88 meters per second, and that is our Vx. So I'm going to go ahead and plug that in here for our initial velocity in the x direction, 4.88 meters per second. All right, so let's check out the y direction. In the y direction, we know the acceleration, right? This object, from the moment it leaves the ground, is going to be in free fall. Free fall acceleration is little g, or negative 9.8 meters per second squared. Cool. We also know the change in height, right? Delta y is going to be 0 meters, right? The motion that we're concerned with, right, is a soccer ball starting on the ground, right, if this is it, flying up in the air, and then landing back on the ground, right? It experiences no change in height from the initial position, right, over here to the final position. Therefore, the change in height is 0 meters. That's what we're plugging in over here. Again, we don't know the time, little question mark. And we could solve for the initial vertical velocity, right, using the same kind of trig principles here, right? The vertical velocity is opposite the 45-degree angle, so we're going to use the sine, right, of 45 times 9.3 meters per second equals Vy, and this is actually also going to equal 4.88 meters per second. That's Vy. Go ahead and chalk that up there, right? And I find that keeping things organized like this, keeping track of what you know and what you don't know, is really helpful for these types of problems. You don't have to store this information in your brain. You should write it down. In fact, the more of it you write down, the more I can see you thinking, the more I can give you points on the exam. So it really is in your benefit to write down every step that you take. Okay? Right, I have all my information down. I don't think I'm missing anything. If I look over in the x direction, which, this here is my big question mark. This is ultimately what I want to solve for displacement, but I don't have enough information yet, right? I have 2 unknowns and 1 known in an equation. If I plug those in, I'm going to get an unknown. So I need some more information. So I turn and I look at my y direction. In my y direction, I have 3 variables filled in and 1 that I'm missing. So I want to turn to my big 4 equations, right, and find one that has time, right, because we want to solve for time. And the one variable that we don't know right now is v final, right, for the ball in the y direction. So I want to look for an equation that doesn't have v final, right? Because if it has v final, I might need to find v final. I don't know if I know how to find v final. I want to make it simple for myself and see if there's an equation that doesn't have v final in it. And lucky for us, there is. There's one that is displacement, in this case change in height, times the initial velocity, in this case vy initial, equals the initial velocity times time, plus 1/2 acceleration time squared. And this works perfectly, right, because I have all of these variables except for time, right? So I can solve for time using this. Awesome. So I've got 0 meters equals 4.88. I'm going to leave out units because I think I'm going to run out of space, but you should put them in your calculations. Plus 1/2 times negative 9.8. Throw some parentheses in there for some clarity. Time squared. Okay. I'm going to subtract 4.88t from both sides. So I'm going to end up with negative 4.88t equals negative 4.9t squared. I'm then going to divide both sides by t, right, because they have that in common. That's going to make my life easier. Negative 4.88 equals negative 4.9t. Divide both sides by 4.9, and you're going to get that time equals about 1 second, right? So the soccer ball's in the air for about 1 second. Cool, we've solved for the change in time. But we're not done yet, right? The question was asking us about displacement horizontally. So now that we have time, though, we can go back up to our constant velocity model equation, right, and plug it in there, because we have the velocity in the x direction, right? So if we do a little manipulation, velocity x times change in time is going to equal the displacement. And nice that this is 1, because that's some pretty easy math. If you can't do this in your head, we might have bigger problems than our physics exam. Right, 4.88 meters per second times 1 second equals our displacement. So our displacement horizontally is 4.88 meters. Okay, that's your answer. Right, I highly recommend that you follow these steps, right, and write it out. It's going to make your life easier, and it's going to allow me to give you a lot of partial credit, right, even if maybe you make a math error somewhere along the way.